So this is lesson 3, different types of solutions, and our objectives will be to identify the different types of solutions. So let's look. The first one is called an unsaturated solution. You may have heard about this, unsaturated fats, saturated fats, etc., etc. So the idea is kind of similar. An unsaturated solution is a solution in which more solute could be dissolved in a given volume of a solvent. So we're going to say more solute than can be dissolved. Okay, a saturated solution then is a solution containing the maximum amount, the max amount of a solute that will dissolve in a given volume of solvent. So for instance, a saturated solution is a solution that is at equilibrium. And this is very important because when we say saturated, we know that it has an equal amount of everything, solute and solvent. So here are two little visual examples for you to show you how much is actually needed in water to be completely dissolved. So you have 30 grams of sodium chloride and 100 milliliters of water. When we mix those two together, we actually end up with an unsaturated solution which contains 100 milliliters of water and only 30 grams of sodium chloride. So all of the sodium chloride is dissolved, but there's still room to dissolve more in that 100 milliliters. So now what we do is we increase the amount of sodium chloride. We bump it up to 40 grams. We put it in the same amount of water, 100 milliliters. Now we actually have a saturated solution because whatever the maximum amount that the water could hold has now been completely dissolved, and there's just a little bit left over that just does not dissolve. So at this point we have a saturated solution containing 100 milliliters of water and only 36 grams of sodium chloride, and 4 additional grams of sodium chloride then remains undissolved and falls to the bottom. Okay, the third type of solution is saturated or supersaturated. I'm sorry, a solution that contains more solute than would normally dissolve in a given volume of solvent. This usually requires an increase in temperature or pressure. And this is actually very rare, okay? And I will try to demonstrate this in class, provided that I have the materials. Initially, okay, so initially we'd have to increase the temperature and the pressure in order for us to force that solute to dissolve. Normally it wouldn't, okay, and you'd see it settling out. But in the very rare situation, we'd increase temperature or we could increase pressure and kind of force those extra molecules to dissolve in the solvent. So the situation, if you have an unsaturated solution and you add crystals, what will you observe? Think about this. What are you going to see if you have an unsaturated solution? Well, the crystals are going to dissolve completely or disappear. We won't see it. We will see nothing left. Okay? The rate of dissolving is actually greater than the rate of the precipitation or something falling out. Okay, so it happens very quickly. If you have a supersaturated solution, now using this information up here, and you add crystals, what do you think you're going to observe? Okay, well, if it's already saturated and it can't hold any more, what do you think is going to happen? You add crystals, all of the crystals are going to precipitate out. All crystals, again, will precipitate out. Meaning they will fall. Okay, fall out, fall to the bottom completely. And so the rate of dissolving is actually less at this point, less than the rate of the precipitation. So if you have a saturated solution and then you add crystals, what will you observe? Okay, well, if you look back at our example up here, whatever is undissolved then sinks to the bottom. So crystals will sink to the bottom. And then at this point, remember what we said about saturated solutions. If it's at equilibrium, then the rate of dissolving is equal to the rate of precipitation. And that's why we say at this point that it is at equilibrium. Okay, so that actually finalizes lesson 3. What I would like you to do is basically put a little summary in your notes on the 3 different types of solutions and be ready to explain them in class. Thanks guys for listening.